Hi everyone, welcome to the part 5 video, note video for Unit 6. We're moving on to a new learning target today. You'll see that is target 17. So this is the last unit learning target of Unit 6. We started with target 15 and there were a bunch of parts dealing with that. That was Pythagorean theorem. Then we had just a quick session on target 16. That was all about those different side length ratio or relationships that we were able to understand if we knew that we had a 45-45-90 right triangle or a 30-60-90 right triangle. And so then today's target, target 17, it says I can find trigonometric ratios using right triangles and solve problems using trig ratios. This builds on what we introduced in target 16. This learning target is all about ratios and relationships between side lengths in triangles based on what are our angle measures in those same triangles. But whereas we were able to kind of memorize that pattern for target 16 because things change in a very easily to understand way, right? In a 45-45-90, two legs were the same and the hypotenuse was that number times by the square root of 2. In a 30-60-90, our short leg was just a number, our hypotenuse was twice as big always, and our long leg was that short leg number with the square root of 3 multiplied to it. Again, every single triangle in existence actually has relationships between all three side lengths. They're just not as easily memorizable. However, that's where trigonometry comes into play. And so we're going to teach you about a couple different functions on your calculator and a couple of different functions that apply that will help you find these ratios and these relationships and use them to solve for missing sides or missing angles in regular problems and word problems and real scenarios and all that kind of stuff. So without further ado, that's the idea of this learning target. And let's try to understand it and let's try to write some things down and get comfortable. So the first thing that's important is to recognize that this only works in right triangles again. So in our basic triangle here, let's put a right angle in it. It has to have a right angle. It has to be a right triangle for this to work. And I'm just going to label the corners or the angles of my triangle X, Y, and Z. And so basically here's the idea. There are three different um, ratios we want to talk about today. One's called the sine. And the sine is a ratio, and a ratio is just a fraction. We'll talk about what that fraction is in just a second. The second one is a cosine. Again, that is a ratio, meaning a fraction. We'll talk about that in a second. And the third one is a tangent. These are the three functions we want to work with today, and there's a way to go about using all three of them. And again, all three of them, depending on, you got to choose the right one, but all three of them will help us find missing sides or missing angles in right triangles. So here's kind of how it works. With all these trig functions, you have to identify an angle, and you cannot use the 90-degree angle ever. So we don't want to do that. So our choices in this triangle to base everything off of are either angle X or angle Y because they are not the 90-degree angles. They are the other two acute angles. So for this just general piece, I'm going to make a mark here in X. This is just letting you know everything I'm doing here is based off of the angle X. And the first thing you have to do in all these problems is decide three different types of relationships to that angle. Those three relationships are we need to identify the opposite side, the adjacent side, and the hypotenuse. So opposite means from the angle we're talking about, which is X, if I go across this triangle, the opposite side, I'm going to label that as opposite. I always think that's the easiest one to figure out, just looking across from whatever angle we've identified, across from that angle will be the opposite side. The second one that's fairly easy to identify is the hypotenuse. Across from our 90-degree angle is always our hypotenuse, which then by process of elimination tells us that the other side, the side that's attached to the angle we're talking about, that's called our adjacent side. And so we have to be able to label all three of those sides every single time we do a trigonometry problem. We got to know what all the sides are labeled based on the angle that we are referencing, which again in this problem is angle X. And again, those three sides are going to be called opposite, and I'll write it in fully here, opposite, and again that is across from the angle we've identified as reference. We have our hypotenuse, which is always across from our 90-degree angle and is always the biggest side. And then we have our adjacent side, which is always attached to the angle that we are referencing. So not across from the shape, but right next to the angle. Now, let's talk about ratios and fractions here. Once we are able to label these three things, now we can set up our ratios. We can really figure out what the sine, the cosine, and the tangent are. And so your sine ratio, and again, a ratio is a fraction, is if we take the opposite side length and we divide it by the hypotenuse length. Our sine is always the opposite side divided by the hypotenuse. And then similarly, your cosine, instead of being opposite, it's going to be the adjacent side. And then we're going to divide that by the hypotenuse. And then tangent is going to be the opposite side divided by the adjacent side. And so these are our three ratios. We'll be able to do something with sine if we're working with opposite and hypotenuse. We'll be able to do something with cosine if we're working with adjacent and hypotenuse. And we'll be able to do something with tangent if we're working with opposite and adjacent. And this is exactly why it's crucial to identify opposite, adjacent, and hypotenuse every single time you do one of these problems, because you're going to use those specific sides to figure out one or maybe more of these trigonometry ratios. Now, a real quick shortcut to try to remember what's what, we're going to call it Sohcahtoa, and you're going to want to remember this. I'm going to write it in a nice way. So So stands for S-O-H. So that says S-O-H, kind of like this, so. And it means sine is opposite divided by hypotenuse. And then the next piece is Ca. And I'm going to write that similarly. So cosine is adjacent divided by hypotenuse. And then finally, Toa, T-O-A. And what that stands for is tangent is opposite divided by adjacent. So Sohcahtoa. Sine is opposite divided by hypotenuse, and that's what the S, O, and H stands for. Cosine is adjacent divided by hypotenuse, and that's what the C-A-H stands for. And Toa, tangent is opposite divided by adjacent. And so if you can remember Sohcahtoa and write it down even, because visually you can see sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. So if you can remember that and write that down, you will always have this idea of and this game plan of how do I set up these ratios, and then you can go about solving them. Now let's start looking at them and identifying them in a couple example problems here. So in number one, we want the sine of angle A. We have to find angle A. And then we have to think about what's opposite, what's adjacent, what's hypotenuse. Well, actually, if we think about Sohcahtoa for sine, right? And I'll write that down here. Sohcahtoa. For sine, we just need opposite and hypotenuse. So from angle A, opposite would be across. That would be little a. And then our hypotenuse would be across from the 90. That would be little c. So the sine of angle A is opposite divided by hypotenuse. Opposite is A, hypotenuse is C. So I will write A divided by C. And that's it. We're just setting up the trigonometric ratios. All right, now let's clear this because it changes every time we do a different trig function. So now cosine of A. Ca is adjacent and hypotenuse. So we're still working with A. Hypotenuse is still the same side, but this time adjacent is the side connected to our angle. So B would be on the adjacent side. So B would be adjacent, hypotenuse would be C. And so our ratio here, our fraction, would be B divided by C, adjacent divided by hypotenuse. All right, now let's do tangent. Tangent is TOA, opposite divided by adjacent. This time it's talking about angle B. Let's go to angle B. And now across from my shape is opposite. So that would be little b. And then connected would be adjacent, right? And connected and not the hypotenuse. The hypotenuse is its own thing. So connected would be the other side. That would be adjacent. And that's A. So TOA is opposite divided by adjacent. So B divided by A. All right. Now, I know we're going slow here. We'll try to pick it up in a second, but we just want to be very comfortable at labeling these triangles, recognizing the information we have. So let's move to sine again, but this time angle J. So let's find angle J. That's in our other triangle. Sine is opposite over hypotenuse. So opposite would be little j. Hypotenuse, I'm going to call that a L, I guess. Maybe it's an I don't know. I'm going to call it an L. And so sine is opposite over hypotenuse. We're based on angle J, and so that would be little j divided by little l. All right, now let's go to the cosine of k, it says. So let's find angle K. Cosine is adjacent, so cosine is ca, adjacent over hypotenuse. So adjacent is the connecting side. It's little j, and then hypotenuse is across from our 90. And so what you'll see here is the cosine of k is also little j over L. And I want you to take a look at the sine of j and the cosine of k. In this example, they came out as the exact same fraction. And that's crucial, and that happens a lot. I'm not going to try to spoil the surprise for you, but I want you to investigate it a little bit. But if we are doing, basically what I want you to see is, if we label opposite, adjacent, and hypotenuse from one angle, angle J for instance, and then we move to an angle K and we do the same thing, but we're based off of a different angle, the hypotenuse always stays in the same spot, but opposite and adjacent change depending on which angle you're talking about, which is exactly why if you do the sine of one and the cosine of the other, you get this situation where you get the same ratio because the opposite and adjacent had changed, and it actually had changed into a way that it became the same because we flipped angles. Now, with that being said, let's just keep this process going. Let's do the last one, tangent of angle K. You can hear my dog scratching outside. She wants to get into this room. We'll finish up this video real quick. So we're based on angle K. Tan is TOA, opposite over adjacent. So opposite is across our shape. That's little k. Adjacent is the connecting side, but not the hypotenuse. And so that's a little j. So TOA here, tangent of angle K, is going to equal little k divided by little j. All right, so that's all about setting up the ratios. I guess we can do one more quick one here. I have about a minute left of this video, so let's do that. We'll keep the Sohcahtoa in view. Let's try to go a little faster. Sine, cosine, tangent of the acute angles. Remember, that just means never use the 90. We're not going to do this with angle E. We're going to do it with angle F and D. Let's start with F. So we'll go sine of F. And I can abbreviate sine by writing sin. And that's going to equal, and remember it equals opposite over hypotenuse. So opposite is going to be 3, hypotenuse is 5, so this equals 3 divided by 5. All right, let's keep the pace going. We'll do cosine of angle F now. And that equals, right, cosine is adjacent over hypotenuse. So 4 here is the adjacent. It connects to F, right? And so cosine is 4 divided by 5 of angle F. And then finally, that brings us to the tangent of F. Tangent, TOA, opposite over adjacent. So opposite is 3, adjacent is 4. So this will equal 3 over 4. All right, I will pick this back up in just a second on the second part of this video. Thank you very much.